Every single time you send an email or watch a video or just browse the web, you're tapping into this hidden world of digital communication. So today, let's go on a quiet little exploration of that world. We're going to trace the journey of a single message as it makes its way across the internet. Think about it. You click a link and a web page just appears. It feels like magic, totally instantaneous. But in that tiny fraction of a second, your request has probably traveled hundreds, maybe even thousands, of miles through this incredibly complex web of cables and routers. So let's gently pull back the curtain on that everyday magic.
Okay, so let's dive into the really big problem that the pioneers of the internet had to solve, right? You've got computers from Apple, phones from Samsung, servers running Linux, heck, even smart toasters from who knows where. How on earth do you get this digital Tower of Babel to actually communicate with each other reliably?
Well, the solution is actually pretty elegant. It's a shared agreement, a common language that all of these different devices can speak. And in the world of networking, we call this a protocol. You can think of it like a universal grammar for the internet. It's what makes sure every message is understood, no matter where it's from or where it's going.
It's really not so different from how we talk to each other. We have these unwritten rules for conversation, right? You say hello, you take turns speaking, you use a certain tone. Network protocols do the exact same thing, just for computers. They establish this predictable, orderly exchange of information that keeps the whole internet from falling into digital chaos.
So, to really make this idea stick, we're going to follow one single piece of data on its journey from start to finish. And our big analogy for this whole process is going to be sending a letter. It's actually the perfect way to understand this incredibly complex system that's handling billions of these messages every single second.
And here it is. This is our roadmap, the 5-layer model of the internet. It's basically just a way of organizing all the internet's protocols into a stack. And the genius of it is that each layer has one very specific job to do, and it only talks to the layers directly above and below it. This layer design, it's the real secret to managing the internet's immense complexity. All right, our journey starts at the very top, in what's called the application layer. This is the part that you, the user, actually interact with. It's the layer that's closest to us. So let's say you type a web address into your browser and you hit enter. In that very instant, your browser, using something called the Hypertext Transfer Protocol, or HTTP, creates a request. This is the original content of your letter. In networking speak, we call this a message. So yeah, it all begins right here, with this simple message. This is the what. It's what we want to send. Now we just have to figure out the how.
Okay, now that we have our message, we have to get it ready for its long journey. And this brings us down to the next layer, the transport layer, where the main job is to make sure our message gets to where it's going and gets there reliably.
This is where a protocol called TCP, or Transmission Control Protocol, comes into play. If your message is a long one, like a big image file, TCP acts like a super careful planner. It chops it up into smaller, numbered pieces that we call segments. And this is absolutely crucial, because it means if a single piece gets lost along the way, it can be easily resent. And it also means the computer on the other end can put everything back together in the correct order.
So this is our first step of what we call encapsulation. See, TCP takes our message, it puts it in a sort of virtual envelope, and it writes some important control information on the front, like a sequence number. This whole new package is our segment.
So our letter is all packaged up, and it's ready for reliable transport. But where is it going? Well, that's the job of the next layer down, the network layer. You can think of this as the internet's global postal service. Right. The Internet Protocol, or IP, is what adds a new header with the destination and source IP addresses. This is the universal mailing address that every single router on the entire internet can understand. It's what allows them to look at the package and forward it one step closer to its final destination. And here you can see the next step in our little nesting doll of data. Our TCP segment gets placed inside an even larger envelope, a package we call an IP datagram. So now we've got our original letter inside a numbered envelope, which is now inside a globally addressed package.
We are so close to being ready to send this thing. The final 2 layers, the link and physical layers, are all about getting our package from our computer to the very next stop on its journey. Think of it like the local post office, or even just your Wi-Fi router. So the link layer puts our datagram into one final wrapper, which we call a frame, and it addresses it just for the very next hop. Then the physical layer takes over.
It's the one that converts all this digital information into actual pulses of electricity or light to be sent over a wire or through the air. This is the moment our digital message becomes a real physical signal, racing through the internet's arteries.
So, after a journey that could have crossed continents, hopping across dozens of routers in just a fraction of a second, our message arrives at the destination server. And now, this entire elegant process just happens in reverse. The server gets the physical signals and translates them back into bits of data. The link layer unwraps the frame. The network layer checks the IP address. The transport layer carefully reassembles all those numbered pieces. And finally, the original, complete message is handed all the way back up to the application. The letter has been delivered, opened, and read.
And this whole process of nesting envelopes layer by layer actually has a name. It's called encapsulation. And honestly, it's a brilliant solution to an incredibly complex problem. It's what allows for this beautifully organized system, where different jobs are handled at different independent levels. It's what makes the internet both powerful and scalable.
You know, the real beauty of this whole thing is its simplicity. The network layer doesn't have to care about what's in the message, it just needs to know how to read an address. The transport layer doesn't worry about addresses, it just focuses on making sure all the pieces get there. Each layer just does its own small job perfectly and trusts the others to do theirs, creating this system that's so much greater than the sum of its parts.
And when you zoom out, what this really means is that the internet isn't just a physical thing. It's not just a collection of cables and computers. It is a massive, functioning agreement. It's a social and technical contract. The only reason it works is because for decades, everyone from huge tech companies to individual developers has agreed to follow this same layered model, this same set of rules.
So the next time you click a link, maybe just take a half second to appreciate that journey. That feeling of instant connection is made possible by the silent, cooperative dance of protocols, all happening millions of times a second and all built on this simple, layered idea that connects us all.